I'm Anil Kumar sharing with you a question from my student based on ambiguous cases trigonometry. The question is, a triangle has side length of 20 centimeter and 11 centimeter. The angle opposite the later side is 29. That means opposite 11 centimeters 29 degrees. What is the measure of the angle opposite to the side that has a length of 20 meters? Is this the only solution possible for the missing angles? So there are two parts to this. Let me sketch and then discuss the question. Meanwhile, you can always pause and answer. Okay, then look into my solution after that. Here is how I'll sketch. Let me sketch this as the base. We have 20 centimeter and 11 centimeters. Let's say this is 29 degrees is opposite 11. Let's say this is 29 degrees. And we have one side. The opposite side is 11. And let us say, let's just join this point with an angle. Okay, so that becomes our triangle. So we'll call this triangle as triangle ABC. ABC, where the two sides are 20 centimeters and 11 centimeters. The angle given to us is 29 degrees, which is opposite 11 centimeters. We need to find the other angle, which is angle B. That is what we need to find. Now in this, you can see that we are given an acute angle, right? Which is 29 degrees. Acute angle A equals to 29 degrees. So let's check for the ambiguous case, right? Since we are given these two sides an acute angle, let's check for the ambiguous case. Now when do we have an ambiguous case? If I drop a perpendicular here, and if this side is longer than the perpendicular, in that case, we may have two triangles, correct? Now how do we find this side? Let's call this CD. So we know CD is equal to 20 sine 29. 20 is the hypotenuse, right? Sine 29. Let's figure this out. So 20 sine 29 equals to 9.69. 9.69. Clearly, 11 centimeters is greater than 9.69. So that implies we can have two triangles. Right? So we can have two triangles. So let me sketch the other triangle also. We could have another triangle which could be kind of like this, where these two sides are 11. Is it okay? So I'll call this as B dash. So as you can clearly see, we do have two solutions here. Okay. Now anyway, let's use sine law and find angle B first. So we can say, so now we are using sine law. So it's the sine of angle B over the side opposite, which is 20, should be equal to sine of angle A, side opposite is 11. We are using this B first. Okay, so sine of B is equals to 20 over 11 times sine of angle A is given to us as 29 degrees. So let's calculate this. So we have 20 times sine 29 equals to, divided by 11 equals to, this is equal to 0.88147, right? So this is sine B. So we can always find what angle B is, which is sine inverse of all this, right? So we'll do shift sine inverse of our answer, and that is 61.82. So we get angle B as 61.82 degrees. So that is the angle B for us. So we can round this to approximately They're not mentioning anything. We'll just round it to a whole number, 62 degrees. Is it okay? So we get one of the solutions. Says, what is the measure of the angle opposite 20 meters? So we say this angle here is 62 degrees. Now let's look into the second part. Is this the only solution? Well, we have two solutions, right? So we can find angle B dash. Angle B dash, now these two angles are equal, isosceles triangle. So this is also 62. So angle B dash will be 180 degrees minus angle B, right? So which is 180 degrees minus, I'm approximating to 62, right? So we'll do 180 minus 62 equals to 118 degrees. So these are the two possible solutions, right? So our answer is that the angle opposite 20 centimeter will be 62 degrees, or we can say and 118 degrees, correct? So both are possible. So that is how you can actually do it. So I hope it's very clear how to check for ambiguous cases. And if there are two solutions, then the other triangle can be easily solved by finding the angle as 180 minus that angle, correct? So that is how it should be done. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.